Hi everyone, this lesson is for Algebra 2 honor students. This is still Chapter 11, Sequences and Series. Today is Section 11-4. We are going to be reviewing and learning sigma notation as an introduction to a series. So let's get started. This is day 3. So our learning targets, basically if you are given a partial sum, in that notation, that sigma notation, evaluate it by writing all the terms and then adding them. Given the first few terms in a series, you are going to learn how to write S, or using sigma notation. So a series is the sum of a sequence. So we have this sequence, 1, 2, 3, 4, 5. So what they're asking me to do is basically add these terms. So 1 plus 2 plus 3 plus 4 plus 5. And so that series would be a result of the sum. So you would add those. 5 plus 4 is 9, 10, 11, 12, 13, 14, 15. So this sum would be the result of that series. Now, we would use this Greek letter right here, and that means sigma. It's basically an S in the Greek alphabet, but it means sum. So sigma does mean sum. And so what you might see for this series might be this. You could see something like this, where you have the sigma, and you can call these values k, and you would say the first term, which is k equals 1, to the fifth term, so 1 to 5, and you are writing just the value of k. And so this would look like plugging in 1 to k is 1, plus, because sum, sigma is a sum. So the next term, if I plug in 2, I would put that here. Next term 3, next term 4, and then last term would be 5. And so the sum of this series would be 15. There are 3 types of people who know this sum. The Greek people, people in sororities, of course, and fraternities, and math geeks. We're math geeks. This series adds 5 different terms. So we just did that. And so K is that, which I just showed you. And so the result of this, 1, 2, 3, 4, 5, is 15. So with sigma notation, this symbol, this E, is the sigma. It means sum. But you're only adding a part of a series, because this series could be infinite. But we are adding a partial sum, and we're adding the nth partial sum. This value on top, that's the nth value that I want to add up to. So for this series right here that says find the sum of the first terms from n equals 1 to 6 of 4n, then the first term would be 1 time, so you would go 4 times 1 plus, then you'd say 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5, and then lastly 4 times 6, because they're asking you to go all the way up to 6, but they're not asking you to go on to do this forever. So that's why it's called a partial sum. So we're asking you to find the partial sum from n equals 1 to 6. And so the result would be adding these values up. You would go 4 plus 8 plus 12. You would add 16, then 20, and then lastly 24. And then you would get a value. You can add those up. So these are some examples of partial sums or sigma notation. So this says find the sum of the first 4 terms using n. N is my value here that I would plug in. So this is like the first example, but instead of going to 5, we're going to 4. So 1 plus 2 plus 3 plus 4, and that's 10. For this one right here is saying find the values from 1 to 4 of n squared. So that'd be 1 squared plus 2 squared plus 3 squared plus 4 squared. That's 30. Or this one is saying find the fourth partial sum from 1 to 4 of this sequence, or it's a series when you're adding them, 2n plus 1. So you'd plug in 1. So you're like 2 times 1 plus 1. So that's where the 3 came from. Then you would go 2 times 2 plus 1. That's where the 5 came from. Then you'd plug in all the values until they ask you to stop. And so these are plus 1, plus 1. And then you would add the values up until you're done. So try this, pause the video, try this, turn it back on. So I'm assuming you did that. So you would do this, you would add 0 to 3, you would go from 0 to 3. So this is what it's saying. The first term is 6 minus 3 times 0 plus, and these, you could use little brackets if you want, if that makes, you happy or whatever. Then you would go 6 minus 3 times 1 plus, again, 6 minus 3 times 2, one more, plus 6 minus 3 times 3. Now I've used the third partial sum. You got to go all the way to 3. And so we just get these values. So 6 minus 0 is just 6. So you would go 6 plus 6 minus 3, which is 3, plus 6 minus 6, which is 0, plus, and then 6 minus 9, which is negative 3. So when you're finding the partial sum for these 3's are going to cancel, and I end up with 6. And 6 would be the result of this value. And that's all you're doing, is you're plugging these values in. For this one right here, we're going to plug in values from 1 to 5. And so you would use the first term would be 1. So you'd say, I'm going to use brackets also. So I'm going to say 1 squared minus 1. Probably just use parentheses. That would be sufficient. The second one would be plus 2 squared minus 2. The next one would be 3 squared minus 3 plus 4 squared minus 4, and lastly plus 5 squared minus 5. And so we get 1 squared, which is 1. 1 minus 1 is 0, plus 2 squared, which is 4. 4 minus 2, which is 2, plus 3 squared, which is 9. 9 minus 3 is 6, so 6, plus 4 squared, 16. 16 minus 4 is 12. And lastly, 5 squared, which is 25, and subtract 5, and I get 20. So adding these values up, we get 20, 32, 33, 34, and plus 6 is 40. So the series from 1 to 5 would be equal to 40. And this is asking me to write the series using sigma notation. For this problem here, they're saying finding the series, this S of n. So for this case, 1, 2, 3, 4, I've got 5 terms. And so this would be finding the sum of the values from 1 to 5. And so then we would say, well, for using sigma notation, we'd say k equals 1 to 5. And now I need to come up with a formula that is going to represent the values that I have here. So the values I have here, I need to find a pattern. It looks like I've got the first term is 1, the second term is 4, the third term is 9, the fourth term, etc. So seeing a pattern between the first term and 1 is not too obvious, but as I go through and I see a pattern between the second term and 4 and the third term and 9, it does look like I'm squaring each of these terms. So if I did plug in 1, I would get 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And now I've got a sum of the values from 1 to 5. And this would be 25 plus 16 plus 9 plus 4 plus 1. And this does represent what we had here in the beginning. So we've definitely written this as sigma notation, which is this value right here. That's it for today. Given a partial sum, use sigma notation, evaluate writing the terms and adding them. And given the first few terms of a series, you need to be able to write the sum of that series using sigma notation. You have homework. It's going to be every third problem. So you're going to start with 3, and your next value would be 6, then 9, then 11, and so on. So thanks so much for watching, and I hope this helped you.